Okay, guys, how are ya? Let's move on to the next problem that I'd like to take a look at. And this one is Canadian population was 32.5 million and growing at a rate of 1 point, excuse me, 78% per year. We went over this in class, but of course I would like to revisit it. I don't know why these things keep popping up. I don't want that. Um, I want to revisit this, and it says the growth rate remains constant, assuming express your population of this country as a function of t in the number of years after 2006. So this all starts in 2006. Now, if I give you something, first thing you should realize, and I should have asked you this first, is this a linear or exponential growth? And you guys are all becoming very good at recognizing that this, in fact, is exponential growth because you have a percentage of increase. So what this is saying is that if you start off with 32.53 million and you're growing at a rate of at a rate of 1.78% per year, that is literally saying, I'm going to go into here, let's quit out of this baby. That's literally saying that you are growing 32.53 and you are multiplying that times 1.0178. So you're asking yourself, like, why, like, what's up with this one thing? So this right here is almost saying that what you're doing is you're adding 1.78% of 32.53 million back to 32.53 million. This is saying, let's just do it in one fell swoop, that this is the 100%, which is that 32.53 million plus whatever 0.178% is. And if I press enter, that means population in 2007, because in 2006 it was 32.53. So now in 2007, it's going to be 33 point yada, yada, yada. So now if I hit times again, that 1.0178, it's telling me that in 2008, my new population is going to be 33.69 whatever. So if I press enter again, how nice is that on your calculator? You didn't know it did that. So if I multiply it by that same number again, it's 2009, 2010, 2011, 2012, 2013, and so forth. So you're knowing that it's exponential. You're growing exponentially because you are multiplying by 1.0178%. Now, if you said to me, you know, Schwa, like, how do I know what the percentage of increase is? Like, I could give you tables and we'll talk about that in a little bit. But if you were to take this, and here's what I want you to do. Take this number right here. And if you divide it by this number right here, do you want to guess what that number would be? Let's find out what it is. 36.80621,757, right? You should be doing it too. And if you divide it by the previous number, I'm going to put my money down. I'm going to bet $1 million. Now, I'm going to bet more than $1 million. I'm going to bet $1 trillion. And I don't have to work again. I can actually save the world with that money. 463. I'm going to bet that it is 1.0178. Wow. Doesn't it make sense that if you multiply, that if you multiplied, if you multiplied this times this to get this, then this divided by this would give you that, right? It's just going back to your basic math that the inverse operation of multiplication is division. So getting back to what's been happening here, the beautiful thing is we are multiplying by the same number every time to get our new population. When you multiply by the same number every time, that's pretty much telling us that in the equation of y equals ab to the x, that tells you what your b is equal to. So your b, just so you know, I'm going to put that in pink. Our b is equal to 1.0178. And it should make sense that b is going to be greater than 1 because we're multiplying something, if we're multiplying by something greater than 1 means that we have something that's growing. Think about that. If I multiply by something that's greater than 1, my numbers are going to keep getting bigger and bigger. So this number here has to be greater than 1 if we're growing, but if we are decaying, then this number should be less than 1. So with that said, how we got this b over here is, remember, your 32.53 million represents 100%. That's what you always start off with. Your initial amount is always 100%. you're growing at a rate of 1.78%. So that's equal to 101.78%. Back in the day when you learned a little bit of math, to go from a percentage to a decimal, you multiply your decimal places over 2, which is why it becomes 1.0178. Okay? Now, we have the b in our equation, and a is simply our initial amount, our initial population. So if you go march on over here, we should all say, that is our initial population. So now, let's get cute with this because it's saying express the population p as a function of t. So it's basically saying that this is p and x is t. So that means we would write it as p is equal to our initial amount, which is 32.53 million, and then b is 1.0178 raised to the t power. So that's the population is a function of time. So in other words, the population depends upon what year it is, or what time it is. So the domain is your years, right? And your range is your population. That's what I mean by determining the domain and range. So graph the function on your calculator, determine the window you will use based on the domain and range of the function. Okay, so now that we have this in our pockets, let's march on over to our graphing calculator. Okay, so we're going to go into our graphing calculator. Let me clear all this out. And I'm going to go into my y equals, and I'm going to clear that. And I'm going to put my 32.53 and then times my 1.0178 raised, closing that out, raised to the x power. Now, if it's in years, again, there's no wrong answer. I could probably give you years to try. So like, I don't know, let's find out what the population would be over the course of, let's get crazy, 25 years. Okay, so we'll go from 0 to 25. And in this instance, by the way, what is typically your minimum y value in this case should be what? And remember, who's y again? That's right, it's your population. So now you want to ask yourself, what is my minimum y value for y? And if you said to yourself, 32.53 million because it's only growing from there, we should be good. But again, you can press that zoom 0, okay, because it's your zoom fit key. And you'll notice you have something that looks like that. Now, it doesn't really look like it's exponential, but it's certainly not linear because you can see it's actually bending. So to see what's really happening here, okay, because remember, this is in millions, by the way, you can take this up to, let's say, 50. Let's see what the population is going to be in 50 years. So let's press a little zoom 0. And you can see it's got a little bit of a curvature to it. Now, the reason why it's not that crazy, why don't you tell me why it's not that crazy? Exactly, because the growth rate is under 2%. It's like a 1.78%. That is a slow growth, okay? So it's a very slow growth. So this is over the course of 50 years. So now if you look at your window, so now your population in 50 years, according to this model, will get up to 78.5, almost, wow, like 70, almost 79 million people. That is a lot of people. So anyway, let's go back to the graph and let's go back to the problem because there were some nice questions I asked you based on this problem. So where am I here? Okay, so getting back here, it says, determine the window you're going to use. So we pretty much opted for, we said, okay, we're going to let our We're going to let our population, our time is going to go from 0 to 50. And then over here, it doesn't hurt to put years for my domain. Okay, so domain 0 to 50 and then years out here. And then your range is going to be, according to our model, 32.53. And then it's going to go up to that 78 point, I don't remember whatever that yada, yada, yada stuff was, millions, okay? We're going to put population in millions, okay? Because one of the most important things I want you guys to understand is I want to know, who does the domain represent? Does it represent the number of dogs, cats, years? What does it represent, okay? Now, the next question I'm asking you is, what will the model be in the population according to the model in 2018? Well, if year 0 is 2006, then 2018 is, you guessed it, 12 years later. So now we have y is equal to 32.53 times 1.0178 raised to the 12th power. And you could do that on your calculators. You could also go into here and you can do calculate value, because this is a calculator question. So up in here, you'll see right there, it says calculate. So if I do second calculate, and number one gives me the option of a value. So if you notice down here, it's prompting you plug in a value for X. I'm going to say 12 years. So if I plug in my 12 years, it tells me right here that my population after in 2018, which is 12 years later, is going to be 40.2 million people. So that would be the answer to that particular question. Okay. So this would be, and again, you could just do it on your calculator. So 40.2 million. Again, you know I'm going to want my units. Okay. So then again, it's saying what will the model be in according to the model in 2026? Well, 26 is 20 years later. Whoops, I almost dropped my pen. I'm such a klutz. Okay. So in 2010, again, you're going to press that second trace key, and then number one is your option. And we're going to put in 20 years later. So the population is now 46.29 million. So you can do it that way, or you can just plug it into your calculator and do a little number crunching off to the side here. So you could easily do, you know, 32.53 and then times. If you just put parentheses, it knows it's times 0.0178. Close that baby out, and then you can raise it to the 20th power. And you can also calculate it that way, and you'll still get your 46.29 million people. Now, the last question on here is the one I find the most intriguing and exciting to take a look at. So it's asking you, according to the model, what will the population, this should say when will the population, damn it, it should say when. Charlene, when will the population reach 42 million? So I want to know, when are we going to hit 42 million, and what year? That's what I probably should have said to you, in what year? Shame on me, in what year? So this should actually say, according to the model, in what year will the population reach 42 million? When I'm asking you, when will it reach 42 million? 42 million is the population, so that means I want to substitute in 42 for Y, okay? Now, you guys don't know how to solve exponential functions algebraically yet. You will. But the nice thing is that if you go to your calculator and you go to your y equals, we have our exponential function here, right? Now I want to know, and now remember, it's y equals 32, so this is going to get you, so this right here is going to get you the population at a certain time. If I want to know when the population is going to be 42 million, I want to know when y equals 42 million. So in y2, I can just type in 42. And if you think about what y equals 42 is, y equals 42, my friends, is a horizontal line. So I am basically going to find out when I press my graph key, that point of intersection is going to tell me when. And if you remember, to get that point of intersection, we do second calc, and we do 5 as intersection, and you just move your cursor to the left until it looks like it's pretty close to that point of intersection. Okay, mine's a little erratic. You guys, it should be easier for you guys, like tick tock, you don't stop. My goodness. Okay. Okay. So we're right here. And then it says, if you notice, it says your first curve. Yeah, this is where I think the point of intersection is. Your second curve. Yeah, press enter again, and then press enter again. So it's gonna take, if you look over here, so the population is 42 million, and it's gonna take 14.48 years, which is almost 15 years. So 15 years from 2006, my friends, is, you guessed it, 2021. So it's going to be the year 2021. So I'm going to do another problem after this one because it's totally worth it. Actually, no, let's go back. And let's say I want to know when the population is going to reach 80 million. Okay? So if I type in 80 and I press graph, I like how that's coming up. Oh, it's not on here, so it's way beyond this. So if I want to know when it's going to reach 80 million, notice where my y maximum, I just went into my window, my y maximum is only at 78. So if I put that at 100 and I press graph, check this out. It barely misses it again, so I'm going to have to, if you look over here, I'm running out of time. If you look over here, it's as if I haven't gone far out enough on my X window. So after 50 years, I might put in 80 years. Let's see what happens when I do that. So do you see how I'm messing around with the window? Because here's my point of intersection, so I can find out when that happens. So for you guys, don't be afraid to mess around with that. and we'll do another one in just a moment.